Hi, Marisa. This problem gives some practice in uh, switching back and forth between the exponential form of an equation and the logarithmic form, its inverse. Um, so I put down the original equation you're given and the form you want to get it into. Now, just like with polynomial equations, if two equations were going to be equivalent to each other, all the terms would have to be equivalent. That is, the coefficient of the x cubed term would have to match the coefficient of the x cubed term in the other expression. It's similar to that here. And you see that when we take the logarithm of both of these forms. So taking the logarithm of both sides of each equation, using the law of logarithms that says that the logarithm of a product is the sum of the logs of its parts. So doing that with a natural log here, dividing that up, and same with the form that has the a and b yet to be found. Then we can, since we have one part of this with the log of e, which comes out to be just 1, and the fact that you can bring an exponent down when it's part of the argument of a log, we get an equation here in the log of y and coefficient times t. Over here, we get the same thing, but with a and b. So now we've got to match these up, and we take the parts that are of the same type and find that, well, they can only be equal if a is 25. And then we take the parts that are coefficients of t, and they have to be the same. So the log of b has to equal 0.077. Then switching back to an exponential form, we just say b then is equal to e to the 0.077, which is very nearly 1.08. So results in this equation in the form desired. Y equals 25 times quantity 1.08 to the t power. And I hope that helps.